Hey, whoa, Louis. Whoa, whoa!
Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Brought to you by UFS, the United Fluid System, delivering ocean currents and weather patterns all over the globe.
Everything that we can touch is either a gas, a liquid, or a solid. Now, solids are solid. Liquids and gases move. They're fluids. They flow. The air we breathe is a fluid. The ocean is a fluid. The Earth's crust is made of plates that move around on molten rock. It's a fluid. Now, fluids take the shape of their container. Fluids slide past things. And think about it. If there were no fluids, our whole world would be frozen solid. Take a look at this. It's our fluid flow containment stairway of science. Watch what happens when I pour this vapor down the stairs. It flows. It flows. It flows. Just like water. We can move through fluids, like when we swim in a pool or walk through air. We can't move through a solid. This is a bunch of marbles stuck together. This chunk is a solid. Now here's a bunch of marbles, but they're loose. They take the shape of their container. I can stir them.
Having fun, Bill? Bill?
Or even pour them. The marbles are like molecules of a fluid. You see, fluids flow, and that's important.
Whoa! It's flowing!
Fluids are cool.
No, they're warm. That's why they rise.
But then they sink when they cool.
Good point.
Groovy.
Imagine a world without fluids. No water. That would sure make swimming difficult. And forget about all those other beverages in your refrigerator. Of course, it wouldn't matter that you couldn't breathe because you wouldn't have any body fluids. You'd be a complete solid. A world without fluids would be interesting.
When a solid, like me, passes through a fluid, like air, there's air resistance, friction. What we scientists call aerodynamic drag. See, that's why you crouch down when you ride a bike like this. If you stand up, boy, there's a lot more drag. Now think about it. Everything. Fish, birds, otters, airplanes, rockets. and my helmet are all shaped to reduce drag. Otherwise, getting through a fluid would be a lot more work. Of course, I mean, it's not that hard. I mean, I'm in a wind tunnel.
The shape of an object passing through air or water has a large effect on the resistance offered. When we curve the front of an object of this kind, we notice that the resistance is less, and when it's perfectly streamlined, the resistance is at a minimum.
Have you figured out that air is a fluid yet? You got that part? 'Cause I don't want to hear anybody saying, what? Air is a fluid? I didn't know that. Now you know.
How can big, heavy planes fly in thin air? Please consider the following. This is a hovercraft. It floats on a cushion of fluid. When air flows into this precisely shaped flow containment annulus. We made it from a trash bag.
Nice.
The flow of air comes from the fan in this leaf blower. It's a pump, and it forces fluid under this wooden disc.
Oh boy.
There's enough fluid, and it's flowing fast enough to hold it and me up.
Careful.
I'm flying
Bill.
on a cushion of fluid. There are fans in here, too. Big ones. When those blades start spinning, they run into molecules of fluid, molecules of air. The air gets pushed aft, backwards. See, it's a giant pump. When the engine forces the weight of all that air back, the plane gets shoved forward. When the wing gets pushed through a different part of the same fluid, the good old air, well, some of the air gets pushed down. The weight of the air being pushed down makes the weight of the plane get pushed up. Here it's about 40 tons. If you happen to be on board, well, you go up with it. Feel that wind? That's the fluid being pushed by the plane. Woohoo! Air is thick and heavy. The plane has to fly because it's moving all that fluid around. Well, thank you for joining me on Consider the Following.
Check this out. If you take an empty glass and try to push it underwater, the air in the glass pushes against the water. By tilting the glass, you let the air escape. Now, since air is a fluid, you can fill the glass up with air again. You just need to pour some air into the glass. Take another glass and push it underwater like before. Tilt the glass and let the air out and catch it in the glass filled with water. Keep doing this over and over. You can pour air from one glass to another underwater because air and water are both fluids. They both take up space. They both move around pretty easily. They're
Fluids. Secret.
Take a look at this. It's our hot fluid flow fixture of science. It's a bucket of water with a heater in it. Watch what happens when we squeeze in a little dye and then turn the heater on. The fluid starts to flow up. The heater makes the water warm. Its molecules start moving faster and faster, and they spread out. They expand. Then the cool fluid around it squeezes the warm fluid up. It's convection, natural convection. It's the same thing that makes the wind blow when air over the land is warm, and then cool air from the ocean rushes in to push the warm air up. It's what makes ocean currents flow. It even makes the gigantic tectonic plates of the Earth's surface move around. It's convection. Natural convection.
The water nearest the flame becomes hot. It expands and becomes lighter than the cooler water on top. As the cool water moves down, the hot water rises. This transfer of heat by currents in a liquid or gas is called convection. The moving streams thus created are called convection currents.
Hot fluids will rise up above cold fluids. You can see how this works with 2 bottles, a flashlight, and a playing card. Fill 1 bottle with really hot water from the tap. The hotter, the better. Add some food coloring so you can see it better. Fill the other bottle with cold water. Add a different color food coloring to this bottle. Put the playing card over the cold water bottle and flip it upside down. Carefully set the cold water bottle on top of the hot water bottle. Slide out the card. Use a flashlight so you can see better. The hot fluid rises. It squeezes up into the bottle, pushing the cold water down. Cool, huh? Now what do you think would happen if you put the hot water bottle on the top and the cold water bottle on the bottom? Try it!
This portion of Bill Nye the Science Guy is brought to you by Fancy Fluid Carrying Cases. Watch your fluids take our shape.
For real? That's Bill? Warmer fluids have faster moving molecules, so they rise and cooler fluids sink. Warm fluids rise. 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 I didn't know that.
You can make your own hot air balloon right at home.
Extreme caution.
Extreme caution must be used in performing this experiment. Repeat, extreme caution. Just take a thin plastic bag and use a hairdryer to fill up the bag. The hot air from the hairdryer will push out the cold air, like this.
Probably one of the most fascinating space phenomenon to watch is the unusual behavior of water and other liquids in the orbital environment.
Okay, now you can see that it's really necking down in the middle. It's more or less an unstable configuration here. The piece is trying to fly apart, but the surface tension of the water is holding together and they're fighting each other. And the 2 different forces are more or less battling it out, and then there they go.
Ah. Now that's cold, because I packed the cooler myself and put the ice on top. Air is a fluid, and warmer fluids rise while cooler fluids sink. Put the ice on top, and the air cools. Its molecules start to move slower, and they sink. This cool air will keep the sodas cold.
This is the People's Quart. She says he drank her hot chocolate. He says it left the cup by itself. Join us now for the People's Quart and the case of the flowing fluid.
Your Honor, when I left the room, the defendant was alone with my beverage. When I returned, it was empty. There's no other explanation. He drank my fluid.
Your Honor, I've tried to explain this a million times. Warm fluids rise. Warm fluids rise. If this is true, Your Honor, then it can be deduced that the fluid rose out of the glass by itself.
Your Honor, hot chocolate takes the shape of its container. It doesn't float freely around the room. I want my fluid!
You can't handle the fluid! There still is fluid in there anyway. Air is a fluid.
I mean, I want my hot chocolate!
I want my hot chocolate.
Okay, that's about enough. I'm not going to take this from you anymore. Listen, you drank it! You drank
Order in this car. We'll take a short recess, and I'll return with my verdict. The defendant has made the claim that warm fluids rise, and that the plaintiff's hot chocolate rose out of a mug by itself. Well, the question here is whether or not a warm liquid would rise out of its own container. Now, although this may be true with gases, it is not true of liquids. Judgment is for the plaintiff.
Oh, that's burnt. There's a couple quarts low, too. This thing is going to seize up on you if you don't get some oil in this deal.
I think what he's saying is that the engine lubricant molecules have been deformed by the thermal stress of combustion and the cylindrical tribological surfaces.
Well, I would recommend a high viscosity oil. You might want to go with a 40 weight in it.
The viscosity of a lubricant refers to how thick it is, how easily it flows. Now, engine oil molecules are long. They can be pumped easily under relatively low pressures, around an atmosphere or so. But under high shear stress, they stiffen, and they can support bearing loads up to 5 megapascals.
I think what he's saying is that when things rub together, there's friction. And see, oil is a thick, slippery fluid that keeps the metal parts in that engine from rubbing on each other. Like, well, here, come and take a look at this. See, these marbles is like oil. And if you put the oil in there, it allows two solids to slide past each other. Fluids flow.
That's just what I was driving at. That's just what I was trying to say there.
Liquids and gases are fluid. Their molecules slide past each other easily, and they take the shape of any container they're in.
Welcome back to Pet Rock Theater. Tonight's episode, A Fluid in the Family.
I want to be a viscous fluid.
Huh?
Huh? Like our neighbors, the beverages. Look how happy they are taking the shape of their containers.
But baby, you were a fluid. You were once molten rock deep within the Earth's crust. When you cooled, you became solid.
And now fluids flow around you. Oh, you're right, they do. Wow, fluids flow around me. I'm solid. I'm an X-fluid. I'm gonna go splash some fluids around.
These things we call eddies are actually just a vacuum behind a rock in the river. You need to be able to read rapids and be able to read the shape of rocks to be able to send you in the right direction. The only way to kayak successfully is to be working with the water. That's what we call getting trashed, because you're not in control anymore. The river's tossing you around.
Cool and refreshing.
Those
Most fluids are one bad.
Shut your mouth.
But I'm talking about fluids.
I can dig it.
Take a sip. Change the shape of it. Step on a fluid, and through it you will slip. If you're a liquid or a gas, you're a fluid. If your shape will not last, you're a fluid. If you're the air we breathe, then you're a fluid. Now fluids can change shape, flow around, and circulate. Take a liquid or a gas, and you will know what you have. A fluid. Fluid's good. If the container is around, so's the fluid. The air moves all around, 'cause it's a fluid. The water's pouring down, 'cause it's a fluid. We need fluids. Fluid's good. I like fluids. Fluid's good.
Well, that's our show. Thanks for watching. If you excuse me, I've got some crow instability chronologies to analyze. See ya!
Produced in association with the National Science Foundation.
Fluids or not fluids? That is the question. Whether these things shall be considered liquids or solids remains to be told. To stretch, to bend, perchance to change shape. But does the ability to change shape make these things liquids or just relatively weak solids? There is the rub. Shadow, you are a delicious dessert. But what are you? Alas, poor in-between substances. You perplex me so.